Okay, wait a second. So I will try to discuss little bit more about the materials, methods, and the devices. Actually, it's a very broad topics. The materials, the methods, the devices. There are so many materials, so many methods, and the devices. So just like when we go to the market and buy something, then we say that this is my thing, and this is uh, it belongs to only my like this. So the not exactly that way, but I try to talk on the materials with which I worked and gained some knowledge and wanted to share with all the participants who are presented here. So my outline, but today's talk consists of the few challenges, introduction, and as usual. So rather than talking about the materials, methods, and procedures, like what technique we use, like XRD, XRR, X-ray reflectivity, SCM, this. So overall, for this talk, among my colleagues as well as the senior respected sirs, if they are present here, or especially to the juniors and the students. So I wanted to share how it can be gone through the research career and so what because the new students and the new generations are definitely they have to go beyond than us. It should not be limited. It should not be limited just as we did. So let me start with the acknowledgement. Of course, when I joined or when I chose the physics as a major subject or a specialized subject, or according to my interest, I affiliated with the Tribhuvan University, and as already introduced by the Professor Dr. Binila Aryal sir, like I graduated from the Kent State University, and at that time I worked for the NSF National Science Foundation project for the characterization of, actually what I do is the characterization of material. Material means different types of the materials. So my materials, actually, I don't have to say that my materials, our materials, like the some and different kinds of the liquid crystal materials. And most of the time, what we do is the characterization part we do at Argonne National Lab, the Department of the Energy. So I'm very thankful for giving opportunity to work as a user for the 3 times. And so, but that was my previous experience. So let me just introduce academic career. Like currently, I'm working as a head of the department at the physics department of the Amrit Campus. Amrit Campus, which is one of the historical campus of the Tribhuvan University, and with a great mission of contributing science and technology of the Nepal. The late Professor Amrit Pradhan founded the Amrit Campus in the 2013. At that level only, the very intermediate level like PCL, we call as a proficiency certificate level, equivalent to the +2, was going on. So after in the third decade of, it is already the 6th decade. So around the 3rd decade, the bachelor levels of the physics education is started. And in the 6th, like from the 2010, actually after I returning from my PhD and the postdoc from the Kent State University, the same year, we could initiate, due to the high demand of the physics, we could initiate the master's level, and including the research work from the 2010. So when we start the new things, or there is always the challenges. not only in the research, in our everyday life also. So when we accept the challenges, there will definitely be the opportunities. So my area is, I did some experiments in the United States as well as in the Nepal. So I wanted to continue in that area. So, but the challenges in front of us are the in, the like basic, even though we don't have the basic infrastructure or basic scientific equipment and the labs for going the experimental research. Like these are the, I listed like few of the problems. So uh, it's not very good that we always say that I don't have this, I can't do this, I can't do this, and we don't have this. So these are, even though we have the challenges or the problems. So if we accept the challenges, then the opportunity that just like the cause and effect. So if you like think that we can do this, after this, then we will look forward or see the solutions for that. So definitely I just listed some of the challenges and opportunity like this. So with this, I could initiate the experimental platform for the research work. I mean, in the experimental research. And so it was we started the master's degree program uh, having the very financial say that the crisis, or we don't have sufficient finance for this, but uh, but actually we started what can be done. So I remember that one day the Professor Binil sir is saying that in the like Shok Sabha of the our Shankar Prasad Pradhan, late Professor Shankar Prasad Pradhan's Shok Sabha, that we always remember, you have to remember the how many hours we have to think rather than just reading, writing, and preparing for the exam. So this way, that if you think something, then the solution, going for the solution. So I just say that I could initiate the platform for the researcher, and which definitely for the higher level, uh, running higher level like the masters and the PhD, then without research. So it is no meaningful, which I learned from my international experience in my academic career. So it should be both parallel this. So this way we can upgrade the education calendar. So definitely in among all the participants, we all know that how important is publishing our work. So if you accept challenges or some problems, you will definitely get something. So publishing our work is a great matter for us. So the materials. So as I said before, there are lots of materials. I just want to share my knowledge, like I worked to characterize the few of the materials here. Among many, I picked few of the materials, like the different types of the the different shape of the molecule we work for. Because in the liquid crystal system, the shape and the size of the matter, it is a vital part. So like this rod-like molecule that forms the uniaxial pneumatic phases, whereas the same thing, but if the shape changes, then it goes for the like banana-shaped or bent core molecules. then it forms the addition to nematic, it shows the biaxial nematic phase. So this was, this is the A103 and A131. This was very important in my life because I learned the characterizing of this phases formed by this bent core molecule forming the biaxial nematic at the time, and it was published in the JACS, which is a very significant paper. And so I learned the many things with this material. So another material for me is very important. So is the sunset yellow molecule. Actually, perilines and the sunshine, these have a like different shape than my previous molecules, like the rod-like and the bent core molecule. So these are the, actually, it's a very common material. So for the research, I would say that the choosing material is very, very important, right? Very important. So in the, and in a liquid condensed matter or liquid crystal system, that is, shape is very important. So like this micelle is sodium stearate or static type of the molecule, like hydrophilic and the hydrocarbon parts, they form the micelles, and assembly of the micelles gives the different phases, like the lamellar phases or cylindrical phases or something like. But if you have a broad-like molecules, just like you see, like assembly of the coins. So this is the basic idea that forms the columnar phases of the columnar phases of the liquid crystal molecule. So this way, the sunset yellow and these two materials are, I got the opportunity to in-depth research for these two materials in my PhD work. And I also worked for the biophysical journal, like ceramic phosphate material using the X-ray reflectivity, which is little bit complex, and we say that difficult experiment, which I got another chance to experience with that experiment also. And this is a kind of the polymer with the liquid crystal. So the different varieties of the molecules I try to experience. Right? So in the in the polymer, so basically, so why we characterize these molecules? Because definitely each have the different applications. So like polymer or this LC, liquid crystal elastomer, they can be used for the tissue scaffold. So definitely for the biomedical. And this is sunset yellow, which is a very yellowish compound and is used for in the many biomedical as well as the food technology applications. So choosing material is very important, as I said. So this was my the past experience. Right now, I have to choose the material to work in Nepal. So as I said before, the problems and the challenges are still there. How to choose the material? Some compounds are very expensive. We don't have the sufficient budget. So, and think that way also. So this currently I'm working in the ZNO, CZTS, SNS, which are very cheap, but it's the dynamic multifunctional materials that can be used for the many devices such as the solar cells and the sensors. So this process I decided to carry. Even without a limited budget, I could do this. And after choosing material, there is definitely the different processes, or we call as a method, how to prepare as well as how to characterize the chosen material for the set objectives. So I tried. So if we search for the different methods, like preparation methods, spray pyrolysis, and these are the very, I listed the very basic, or the I should say that the economic methods. Right? Rather than this, in the experimental section, there are a lot more advanced techniques and sophisticated techniques are available, which I cannot afford, and I just listed here what can we do in the Tribhuvan University or at the physics department of the Amrit campus. So I bought the spin coater and the chemical bar deposition, which I could do this, and for the hydrothermal, these are the some of the economic methods I used. I could this, and so spin spray pyrolysis and the deep coating, with my growing group, the deep coating we were able to design and construct the computerized deep coating method also, with the demo version of the prepared method I will show at the last of this talk. So simply I have some experience, as I said, like the characterizing tools for this. And so this is just a picture where I got an opportunity to work at the Urban National Lab, where we use the Singleton Radiation, the radiation emitted by the fast moving, close the velocity of the light. They are absorbed by the using different mirrors, and then so this is the Xray diffraction pattern of the sunset yellow. This is a dye compound dissolved in the water, and they form the building blocks. And assembly of the building blocks, that gives the liquid crystal phases. Two major phases we detected, and quantitative analysis, like the 19 angstrom and about the 18 to 13 molecules, assembly of the molecules, that gives forms the building blocks. And so similarly, the one question, like why should we go for the Singleton radiation? It's not because of the high quality, it's not because of the X-ray is very great and different than from the lab developed, but it's there is the MAR aerial detector, which is a very high resolution, and at the same time during a scanning we could do some alignment for the capturing the picture. So that was the advantages. So this is the simply the schematic model for the formation of the two phases. One is nematic and the one is the columnar phases. So here is the, maybe this is useful for the students who are new in this area. And like here we all are very familiar with the X-ray diffraction experiment and the Bragg's law. So basic principle is like this, but the small angle that gives the small angle reflection and the large angle reflection. So that corresponds to the two length scales of the molecule. And here, in addition to that, we got the four peaks at the middle angle. That that shows the assembly of the molecule. It's not at the J aggregate or the S aggregate, but it could be something like this, you know, like DNA structure or this. So I put this just to show like the characterization of the different phases from the X-ray diffraction. Okay. Isotropic means liquid, nematic, columnar, and for if you have the chiral or cholesteric phases, then it's similar, but the slightly different length scales. So this is again the same. I'm not going to in detail for that because it's already I talked at so many places. And so another the texture for like tool for characterizing liquid crystals are the N phases, like this and columnar physics. So very briefly, I would say about the liquid crystal elastomer. So this is another kind of the material that forms which leads to interesting properties, thermal actuation and isotropic and the soft elasticity. So first, second, and the third are the different regions. We categorize this. And the interesting region is the soft elastic, where you see that for the very small amount of the stress applied, there is a plateau or the long strain in this region. So this first region is just like the reversible and following the Hooke's law. So here also the orientation of the molecules, here we say that in this case the poly domains. Orientation or alignment of the domains are very important to study the microdomain structure of the material. And again, we use the Xray diffraction and the Xray refraction. So the intensity as well as the position of the reflections. So D means here the layer spacing, like 2d sin theta. D is this, but which layer? And this 2 alpha is because this molecule, the domain that forms the chevron structure, and this alpha is called as the chevron angle. So using X-ray diffraction, so once again, E0, we have 2 rings. E.2, we have the change in, wanted to see the orientation or alignment of the domains. Okay? This. So the zoom in figure of the small angle clearly seeing ring-like and the moon-like. So this showing the orientation or alignment of the molecules. And increasing E, like 0.7, it was clear the separation into the 4 spots, showing the alignment from the polydomain to the monodomain is clearly shifting this. So, and using the Fit 2D and the computer, which we use is a Fit 2D program. So this is the conversion of that diffraction pattern into this one. And this way we calculated the yes as a function, yes, because the LC molecule, it has a core as well as the siloxane parts. So the yes value for the core and the variation, if you compare the variation, it is more like similar, but the yes value, yes means order parameter for the core, definitely the orientation or alignment of the molecule, that is definitely due to the majority due to the yes. But at the same time, the orientation of yes also can be this. So same way, when you have the alignment of the molecules of the material from the polydomain to monodomain, or increasing value of the E, there's the variation of the. So this part and this part. In both cases, like exponentially decreasing D for increasing E, but below some value, it is slightly different. So this way, we also studied the relaxation dynamics for the increasing strain under this. So this picture, just for easiness or for clear view, I said that this is the polydomain and this is the monodomain, alignment of the molecule from the diffraction pattern. So I'm not going to detail. And so this was my previous experience when I worked for the LC and the sunset yellow molecules using the X-ray diffraction. And this one I would like to share with you. Like this is my just recent publication, which is I feel like great, like influence of the DC field on the AC dispersion. This is my recent publication on the Springer Nature B as a Journal of Nanoparticle in the 2020. So what can we done from our lab also, like the AC means the activated carbon. The challenge in front of us, in front of our group was that this person, not only in front of us, the problem of, well, this person of AC has a many, it's a very interesting nanomaterials of the carbon, and it has a many applications for the TCO and the supercapacitor, so on, so on. So this person, before making the film deposition, so will this person of the activated carbon was a challenge. So many researchers have tried to disperse in the number of the solvents. So we usually use the surfactants like the SDS, sodium stearate, potassium laurate sulfate, something salt. But the well dispersion of AC was going on as the challenge. So what we did actually is the dispersion and at the same in situ dispersion of the AC using SDS as well as with the application of the DC voltage. So this is the ultrasonic bath and very simple idea like the ultrasonic bath, and this is my glass bottles or the small vials, and where the two electrodes and the separator, and we applied the in situ the different voltages like 3, 5, 6 and 9 different voltages. So the dispersion of activated carbon through sonation bath, actually if the salt material or compound is well dissolved in the solvent, then maybe ultrasonic bath sonation is enough, but not in this case. And just like while we're washing our clothes, the surf or the detergents, SDS means like semi, exactly that one. So it helps to easy our work. So similarly, SDS. For the dispersion of the AC, we use the SDS. So SDS and greater amount of the SDS helps, but in our research, our scientific work, this SDS, when we add something, this means we call as impurity. So we don't want the more SDS for the easy dispersion. And we don't want the different phases or different destroy the experiment. So we have to optimize as low as SDS and applying this. So how we perform this experiment, I mean the characterizing. So we have the spectrophotometer and the Abbey level at the lab. So we measure the absorbance. Simply, what we got is this. Increasing voltages, the absorbance increases. And these two peaks, the one at the higher wavelength and the one at the around 400. So corresponding to this corresponds to the whitener of the SDS, and this corresponds to the water molecule. So before that, we figure out this, and the absorbance increases with the voltage. So definitely, why absorbance increases? And why absorbance decreases, furthermore decreases? See this figure. Increasing voltages, and after this, after certain voltage, this decreases. First of all, why absorbance increases? And the next one is absorbance, why decreasing? It's not going on continuously. I think most of the researchers or most of the participants will know about it like this. So in the in my experience, is if you get something like this, then the important part is the result you got or you get is like this, but the how you describe and the discussion part is very, very important in publishing your work. So here is the why voltage, applied voltage, increasing applied voltage. In this case, absorbance increases, and after that, and it begins to decrease. So samely, here in this graph, like the weight ratio of SDS to AC. We don't want more amount of the SEO. Do we know that SDS helps to disperse AC in the water? This. So here we can clearly see that without voltage, the this zero means the triangle, and this is the without voltage. The what amount of the what ratio of SDS to AC we require? It's like the ratio is more than 5. I mean, the more surf has to put in the in washing the clothes like that. And here you see this diamond shaped triangle. So applying voltage, it reduces, like means the impurity is decreasing, reducing decreases. So come to this graph. As I said, especially to the if the students are here, then the discussion part is important. Why the um, continuously increasing voltages, it decreases. Yes. So if you have the two electrodes and voltage applied and say negative, and the activated carbons that come close to the negative electrode, and the once the voltage is higher, the goes on increasing, and after a certain value, the uh, the activated carbons which stopped after gaining the electrons from the electrode, then at that time the van der Waals forces, they begins to dominate, and the particles or AC particles, they again they begin to agglomerate, so that the absorbance increases. So exactly the reverse things happens for this case. This voltage applied, the molecule instead of agglomerating, forming aggregates, they begin to segregate, and they attract towards the electrons. So if you have a negative electrons, the activated AC particles close to the reaching the surface, they gain the negative charges and negative repulsion. So they do not follow, they repel, and then so the formation of the agglomeration or aggregation is not happen, so that the well dispersion, in this case the absorption increases. So this way we explained like this, why absorption increases, why after that this. So I think according to our knowledge, so the discussion part is very, very important to make the publication, and the reviewer, they got convinced, like, and so yes, they accepted our work publication. So just we also share, like when we say or send a manuscript for the publication, they say that, oh, in Nepal also, what instruments or what they they begin to question in some cases, not in all cases. So another, the work which we published in the AIP Advances is with my student Madhav Kafle, and in the AIP Advances also. So choosing material, applying methods for characterization, and resultant discussions, everybody knows that. These are very, very important. But the basic idea is how what is Striedler, even though, as I said before, ZNO, it's not a new compound, but still lots of thousands of researchers are working on it for its multivariational or dynamic properties, this that's using the different stages like doping, like we say metal doping, metal co-doping, or the different changing different environment like calcinations, or the plasma treatment, acid treatment. So I'm not going to show all the work I had. So some significant like here the changing the different environment and the deposition. This X-ray shows that the intensity versus 2 theta for the film preparation for the different deposition times. Here we got like the change in grain size. So we also know that the calcination or the even thermal treatment that can change the morphology, which is definitely associated with the it's the grain size in interactions among the particles, grain boundaries, and so that. So in the different environment like nitrogen and the plasma, we got like this. Grain size decreases and increases. So here is a reflector. And so compare these two graphs. So time, with time, thickness, like anyone can say that the deposition time increasing, more samples are putting, the thickness is increasing. But rather than just increasing thickness, that is not increasing the grain size. So decrease under this, increase. So, so finally, I am not going for a long talk, just like I would like to share my research knowledge with my colleagues, my juniors, and the students, like what are the outcomes I could publish, and similarly the to the point I could say that I'm not saying that I did a great job, but I just tried to promote the experimental research as well as I'm trying to motivate some of the faculty members who are always sometimes say that because of my this, because of my that, I could not do that. It's not like this. So the motivate, I wanted to, or I try to motivate. So thank you. Thank you. So finally, I would like to once again thank to my group members. So first one comes to the Professor Shankar Prasad Shrestha, who inspired, who encouraged me to establish and to go ahead. So and other members like Rishi Gimire sir. So I wanted to point at him as a postdoctoral, but because of some processes I could not do, but still he is very much helping in our lab. And these are the faculty members, Pitambar sir, Bal Vikram Khatri, Mohan Bahadur Chetri, and these faculty members, they try to do, they started, many of them, they started the mini projects granted by the UGC and the Dean Office and so on. So finally, the and my collaborators, Professor Yash Kumar, I always thankful to him, and he's my thesis supervisor in my thesis, in my PhD work and the postdoctoral. Now he is the director of the ion beam lab at the University of. So I'm always or still in contact with him for collaborating. That is. So these are my collaborators, and so last but not least, but I'm still looking the international collaborators and working very hard with Dr. Rajendra Parajuli sir and Dr. Sriram Sharma sir for the International Science Program, Sweden. Hopefully, we hope that we could make it and then establish the new science center at the Tribhuvan University Physics Department, Amrit Science Campus. And last but not least, I should thank one of the active group member, the Yogesh Maharjan, and who has, in collaboration with the Institute of the Engineering, and he has constructed a computerized deep coating system. I wanted to show the movie, but I don't, but I don't know it's working or not.
Madam, it will work if you open from outside, probably. This is MP4 file. If you have this file, if you have this file in your desktop, madam.
Oh, because I put in the PowerPoint. So I think it's a very sensitive. When I tried in the desktop, it was working.
It will work, madam, if you open from desktop.
Okay, just 1 second.
And please share that movie through share screen.
Okay.
Oh, yes, madam.
Can you?
No, yes, madam, it's very nice.
Okay. So this is in collaboration with the engineering people, and we use the very sensitive motors for the deep coating. So like this, it's I think it's almost done. So maybe in the next presentation by Yogesh Maharjan or my group or other members, they will talk more about it. So this is very sensitive and with a large range of the from few millimeters to higher millimeter of the film thickness can be deposited. So okay, with that, I will conclude here. Once again, thank you all the participants, thank you organizer, thank you Vinil sir, thank you Raja sir and other co-hosts for listening me, and hope to get more suggestions rather than the questions I will try to answer. If you have I will like to have more suggestions for to go ahead in this research work. Thank you, sir.
Thank you, madam. Thanks a lot for this wonderful talk, particularly sharing your experience working experimental stuff in our colleges. It's really great. Thank you, madam. Now I would like to, because I was out of the connection, so my chat box is blank. I would like to request Raju sir, if you are somewhere
Okay,
to,
yeah,
please
Binit
Raju
sir,
sir,
I'm here.
uh,
Th
for the
Thank you, Leela
question.
madam. Thank you so much for your presentation, and especially for addressing young and the researchers who want to continue their work in Nepal, specifically in material science. So without delay, I like to request participant, if they have any query, to raise hand. Of course, there is one query in the chat which I will start with. And for your information, you can unmute yourself. So please make sure to unmute before asking. But I request you to raise hand. And the first one I request is Raju Bhatrai. Raju, are you there? It's not I'm asking him first because he's Raju, but he's Raju. No, if you cannot unmute or you have any technical problem, I can ask. Please, Raju, go ahead.
Thank you, sir. First, I would like to say namaste for all my teachers. Leela ma'am,
Yes.
I'm also conducting thesis under the supervision of Dr. Momi sir and Dr. Rishiram Gimire at NAST, and it's in sensing property of ZNO.
Okay.
I have raised my question here in my chat box too. Uh, in the transmittance curve of ZNO thin film, some sinusoidal nature is seen. It's almost sinusoidal. Uh, uh, what might be the reason behind that?
It is due to the thickness. It is the interference, due to the interference effect of the film you prepared, thickness of the film. So there are the lot more paper already published in this. So like you could measure the thickness from the sonipple method, or it's a very common thing. So you just follow one or two published reports. It is due to the interference effect of the thickness of the film. You can see this type of the interference pattern only in some thickness. If you made very thin, you cannot see. If you made very thick, you cannot see, due to the interference effect.
Thank you very much, ma'am.
Okay, thank you, Raju. Are there any further queries or anything that anyone would like to share or discuss with Professor Pradhan? Leela madam, before anybody raise hand or ask, just a query, because I'm not in experiment, so I just want to know a basic thing about this system that you have developed. You said Yogesh and your team, they were involved in this one. So what is the minimum thickness? What is the accuracy that it can deposit?